Imagine an aircraft that can lift itself into the sky at dawn and never come down. A plane that drinks sunlight instead of jet fuel, gliding above storms and turbulence, soaring for weeks or even months at a time. The image feels almost mythic. A silent silhouette rising into golden light, powered only by the star that keeps our planet alive. Not long ago, this sounded like a whimsical dream. But today, solar aircraft are crossing the threshold from symbolic demonstrations to practical machines with real-world missions, advanced energy systems, and ambitions that stretch far beyond anything imagined in 2016. What began with Solar Impulse 2 circling the globe is now evolving into something far more important: the first generation of aircraft designed for true long duration, potentially infinite flight. In 2016, Solar Impulse 2 completed its 25,000-mile journey around the world, powered only by sunlight. It was a milestone no one had achieved before. But its real value wasn't the distance. It was the message. Solar flight wasn't just possible. It was scalable. That single mission flipped a switch across aerospace laboratories, startups, defense research groups, and national agencies. It proved that ultra-lightweight materials, precision power management, and highly efficient photovoltaics could combine to create an entirely new category of aircraft. The world realized that fuel-free flight could be more than a stunt. It could be the future. If you want to follow how technologies like this evolve from bold experiments to world-changing systems, this is the place to be. Subscribe, like, and turn on notifications so you stay with these breakthroughs as they unfold. Since that spark nearly a decade ago, the evolution of solar aviation has accelerated quietly but rapidly. High-altitude solar aircraft are now designed to operate far above commercial airspace, flying in thin stratospheric layers where storms never form. Their wings stretch wider than a Boeing 747, yet the aircraft weigh less than a family car. Modern solar cells embedded into those wings now harvest double or triple the energy density used on Solar Impulse 2. And unlike that historic mission, these new aircraft are not attempting to circle the world once. They aim to stay in the sky indefinitely, acting as platforms that blend the capabilities of aircraft and satellites. One of the clearest examples is the Airbus Zephyr, an ultra-lightweight solar aircraft refined for endurance above all else. Zephyr flights have already remained airborne for more than 26 continuous days, nearly an entire month without landing. Its wing surfaces are engineered to maximize exposure to high-altitude UV radiation, feeding power into advanced lithium-sulfur batteries that store enough energy to cruise through the night. When dawn arrives, the cycle resets. In optimal thermal and atmospheric conditions, engineers believe Zephyr could remain aloft for months. And Zephyr is only one member of a fast-growing category. The US Army and SOCOM have tested solar-powered high-altitude drones for persistent surveillance. NASA has funded stratospheric solar aircraft for climate monitoring. Chinese aerospace groups have developed platforms like the Kaihong T4, a flexible wing design reportedly capable of ultra-high endurance missions. These aircraft are not designed to carry passengers. They are designed to replace satellites. This is one of the most disruptive concepts in modern aerospace. Traditional satellites require rockets, fuel, and complex planning. They are enormously expensive and nearly impossible to repair. But a solar aircraft flying at 60,000 to 80,000 feet can provide satellite-level coverage at a fraction of the cost. It can launch from a runway, land for upgrades, and return to the sky carrying new instruments. These HALE platforms, high altitude, long endurance, are essentially solar satellites with wings. Solar cell technology is advancing just as quickly. Solar Impulse used cells around 22% efficiency. Today, the most advanced space-grade photovoltaic cells push close to 30%. In research labs, triple-junction and multi-junction designs have surpassed 40%. According to the National Renewable Energy Laboratory, these cells are advancing faster than predicted, opening the possibility of aircraft harvesting vastly more energy from the same surface area. Higher efficiency means heavier payloads, longer missions, and more powerful sensing and communication equipment. Battery technology is evolving in parallel. Solid-state batteries promise higher energy density and improved reliability in extreme cold. Lithium-sulfur cells tested by Airbus may offer double or triple the energy density of traditional lithium-ion. Researchers at Berkeley Lab and IBM have even reported progress in lithium air cells, ultra-lightweight batteries that could dramatically increase endurance. These advances fundamentally change what solar aircraft can do, shifting the focus from endurance alone to performance and capability. One of the most ambitious examples of this new capability is the Skydweller Aero program. Built as a next-generation evolution of the Solar Impulse architecture, Skydweller removes the cockpit entirely and replaces it with sensors, batteries, mission equipment, and autonomous control systems. Without a human pilot, the aircraft becomes lighter, more stable, and capable of staying airborne far longer. The company believes its aircraft could remain aloft for 90 days or more, allowing it to monitor wildfires, track hurricanes, scan oceans for search and rescue, or serve as a long-duration communications relay, all without burning a single drop of fuel. Before exploring what the next decade holds, take a moment to support this channel. If future-focused breakthroughs inspire you, subscribe, like, and turn on notifications so you never miss what's coming next. What makes the current moment so remarkable is how quickly the barriers that once limited solar aircraft are falling. Solar Impulse 2 struggled with limited battery energy density and propulsion efficiency, but since 2016, stored energy per kilogram has nearly doubled. Lightweight composites have improved dramatically. Electric propulsion systems now provide more thrust per watt with whisper-quiet efficiency. Early prototypes from the University of Stuttgart show two-seat solar electric gliders capable of short training or recreational flights, hinting at a future where human-carrying solar aircraft play niche but meaningful roles. Large aerospace companies are also developing hybrid solar electric designs, where solar energy supplements battery-powered propulsion. Imagine a regional electric aircraft that integrates solar cells into its wings, fuselage, and tail surfaces. Even a modest amount of solar energy could extend range, reduce strain on onboard batteries, and provide emergency power during unexpected conditions. Research from MIT's Electric Aircraft Initiative suggests that under ideal circumstances, solar integration could boost endurance by up to 10%, not a breakthrough alone, but a major step towards sustainable aviation. And below these large platforms, a different revolution is taking shape. Swarms of micro-solar drones, each weighing less than a kilogram, are being tested as autonomous environmental monitoring systems. These tiny aircraft can gather sunlight during flight, making them ideal for long-term missions in agriculture, ecology, and disaster response. Scientists at EPFL in Switzerland have demonstrated swarms that communicate, adapt to weather, share data, and behave almost like living networks. Solar aviation is becoming not just efficient, but intelligent. Solar aviation also fills critical gaps in climate science. Accurate climate modeling requires long-duration atmospheric observations over polar regions, something current satellites cannot provide. A high-altitude solar aircraft could circle the same area for months, delivering continuous data on ice melt, atmospheric chemistry, and ocean conditions. Studies published in Nature Climate Science identify long-duration observation as one of the most vital missing components in climate research. Solar aircraft directly fill that gap. Connectivity is another frontier. Billions of people around the world lack reliable internet access. High-altitude balloons like Alphabet's Loon drift unpredictably. Satellites are expensive, but a solar aircraft can hover in place, acting as a floating cell tower for remote regions or disaster zones. The World Economic Forum has identified stratospheric telecom platforms as a key technology for expanding global digital access. Yet underneath all the engineering lies something deeply human. For the first time, we are designing flying machines that consume nothing finite. No fuel, no exhaust, no roaring engines. Just sunlight, air, and silent electric propulsion. It is a vision of flight that feels almost organic, sustainable, elegant, and in harmony with the natural world. That emotional resonance is part of why the Solar Impulse mission captivated people worldwide, and it still shapes the field today. The long-term vision is even more profound. Imagine a permanent layer of solar aircraft drifting high above the planet, quiet, persistent, and almost alive. Machines that rise with the sun and remain aloft through the changing seasons, descending only for upgrades. These aircraft could reshape global communications, environmental monitoring, and scientific observation. They hint at a future where sustainable flight is not a slogan, but a structural foundation of our global infrastructure. In the end, the legacy of Solar Impulse 2 is not just its record-breaking journey. It is the spark that ignited the transformation now reshaping aerospace. The next generation of solar aircraft is not just more efficient. It is more capable, more purposeful, and increasingly essential to humanity's future. The sky is shifting toward a new era of flight, powered by the star that sustains all life on Earth. And the story has only just begun. If breakthroughs like these inspire you to imagine what comes next, stay connected to the frontier of future aviation and energy by joining this community. Subscribe, like, and turn on notifications so you never miss what is coming over the horizon. This is Tech Mythos.